New Syllabus Mathematics 7th edition, Book 2, Exercise 2E. Question number 1 from this exercise. Two linear equations are given in this question. 7x minus 3y equals 15 and 11x minus 3y equals 21. To solve these two equations, first of all, let's name them equation 1 and equation 2. Okay, we have two same coefficients of variable y in these two equations, which is negative 3 and negative 3. Now to eliminate y, let's subtract equation 1 from equation number 2. So I'll write first left hand side of the equation 2, which is 11x minus 3y, minus left hand side of the equation 1, 7x minus 3y equals right hand side of the equation 2, 21, minus right hand side of the equation 1, 15. Now we are subtracting these two equations because we want to eliminate y. By means of elimination method, we are going to solve these two linear equations. So simplifying this 11x minus 3y, we get 11x negative 3y. Since we have negative sign before this bracket, so I'm going to multiply this negative sign by the first term 7x and then the second term minus 3y inside the bracket. So minus 7x and minus multiplied by minus, we get positive 3y. So after simplification, we get 11x negative 3y negative 7x positive 3y equals 21 minus 15 equals positive 6. Okay, now negative 3y and positive 3y, they will cancel out each other. So we have 11x negative 7x since they are like terms. So let's subtract 7x from 11x, we get 4x and equals right side 6. Okay, to find x, I'm going to divide this left hand side 4x and right side 6 by 4 to eliminate 4 from the left hand side. So in this next step, we know that 4 will cancel out 4. So we have x equals 6 upon 4. So we have common factor between these two numbers, 6 and 4. The common factor is 2. So let's divide 4 and 6 by 2. So we get 2 times 3, 6 and 2 times 2, 4. 3 upon 2 is an improper fraction which can also be expressed as 1 whole 1 upon 2. So this is the true value for x is 1 whole 1 upon 3. Okay, now to find the value of the second variable y, I'm going to substitute this value of x, which is actually 3 upon 2 or 1 whole 1 upon 2 in equation number 1 or in equation number 2. So these two are the first and second equation. So you can put the value of x in this equation 1 or in equation number 2 to find the true value for these two equations. So now I'm going to put this value of x in equation 1. So substitute x equals 3 upon 2 in equation number 1. So equation number 1 is basically 7x minus 3y equals 15. And now since we have the value of x 3 upon 2, so I'm going to substitute 7 into x, which is 3 upon 2, negative 3y equals 15. Now simplification, if we take the product of 7 and 3, so 7 times 3, 21 upon 2, negative 3y equals 15 as it is. To simplify, let's take the LCM of 21 upon 2 and negative 3y. So we get 2 as the LCM of these two fractions, and the numerators is 21 negative 2 times 3, 6y equals 15. And I hope that you know how to take the LCM of fractions. So anyhow, for further simplification, I'm going to multiply 2 on both sides, on the left and right side, to eliminate or to cancel out this 2. Or you can also take or shift this 2 from left to the right side. So if you multiply both sides of this equation by 2, then on the left side we can cancel out 2 by 2. So we have 21 minus 6y equals 15. multiplied by 2. Or you can also take this 2 from left to the right side. Then on the right side, this 2 is going to be multiplied by 15. Now 15 times 2 equals 30, and on the left side we have 21 minus 6y. Okay, now let's take this 21 to the right hand side. Then we have negative 6y equals 30 negative 21. You can also subtract 21 on both hand side, on the left and right side of this equation, and then negative 21 positive 21 will cancel out each other, and then on the right side you'll be having 30 minus 21, because we are subtracting 21 on both hand side because we want to eliminate this 21 from the left hand side. So now we have negative 6y equals 30 minus 21. So if we subtract 21 from 30, we get 9. And now to eliminate 6 from the left hand side, you can also shift this negative 6 from left to the right side, or you can divide both left and right sides by negative 6. So negative 6 will cancel out negative 6. So we have y equals, here on the right side we have common factor 3 between the numerator and denominator 6. So 3 times 2 6, and 3 times 3 9. So we have y equals negative 3 upon 2. Since we have an improper fraction, so 3 upon 2 or negative 3 upon 2 can also be written as negative 1 whole and 1 upon 2, because there's product, or if you simplify this improper fraction, this mixed number, then you will get 2 times 1 2 plus 1 3 upon 2. So now we have two solutions for x and y. So these two, actually the solution of the simultaneous equations is x equals 1 whole 1 upon 2 and y equals negative 1 whole 1 upon 2, which are true values of x and y for these two linear equations. Next part from this question is two linear equations in different variables y and x, 3y negative 2x equals 9 and 2y negative 2x equals 7. Once again we have two like terms, negative 2x, negative 2x. So we can eliminate variable x if we subtract equation number 1 from equation number 2, or equation number 2 from equation number 1. Let's do it. So first of all, let's name this equation, first equation, as our equation number 1, and the second linear equation 2y negative 2x equals 7 as our equation number 2. So since we are eliminating this variable x from these two equations, so I'll subtract equation 1 from equation number 2. So first I'm going to write left hand side of the equation 2, which is 2y negative 2x, and then left hand side of the equation 1, which is 3y negative 2x, equals right side of the equation 2 7, and right side of the equation 1 negative 9. If you write subtracting equation 2 from equation 1, then you will write on the right side like 9 minus 7. Anyhow, let's simplify this step. So we get 2y negative 2x. Now I'll multiply this negative by the first and second term inside the bracket. So minus multiplied by plus, we get negative 3y, and minus multiplied by minus, we get positive 2x equals 7 negative 9 will give us negative 2. Okay, positive 2x and negative 2x, they are like terms but with two different signs. So negative 2x plus 2x will give us 0. So 2y and negative 3y will give us negative y equals, on the right side we have negative 2. Now to eliminate negative sign from the left side y, let's multiply negative 1 on both sides. Then we get positive y on the right side. If you multiply negative 1 by negative 2, then minus multiplied by minus plus, and 2 times 1 equals 2. So we get y equals positive 2, which is the value of y. So now to find the value of x, let's substitute this value of y equals 2 in equation 1 or in equation 2. So if we substitute y equals 2 in equation number 1, then we know that our equation 1 is 3y negative 2x equals 9. since we have y equals 2, so I'm going to substitute y equals 2 in this equation. Then this equation becomes 3 multiplied by 2, negative 2x equals 9. Now 3 times 2 equals 6, negative 2x as it is equals right side 9. And now let's shift this positive 6 from left to the right side, so we get negative 2x equals 9, negative 6. Positive 9, negative 6 will give us positive 3. And to get x alone, so let's divide this equation negative 2x equals 3 by negative 2. So I'm going to divide this negative 2x equals 3 by negative 2. Then we know that negative 2 will cancel out negative 2, so we have x equals negative 3 upon 2. Once again, we have an improper fraction, so you know this fraction can also be written as 1 whole 1 upon 2. So we get the values of x and y for the given linear equations. So the solution of the simultaneous equations is x equals negative 1 whole 1 upon 2 and y equals 2. Next part from this question number 1 is 3a negative b equals 5 and 2b negative 5a equals 9. So here again we have two like terms like positive 2b and negative 2b. So we know that if we if we add them, if we add equation 1 and 2, so we can eliminate negative 2b and positive 2b because they have unlike signs, positive and negative sign. So first of all, step 1 is to name them equation 1 and equation 2, and since I want to eliminate b, variable b, from these two equations, so I'm going to add equation 1 and equation number 2. So first I will write left side of the equation 1 and then left side of the equation 2. On the right side, first I will write right side of the equation 1 and then plus right side of the equation 2, 9. Simplification, positive 3a, negative 2b, positive multiplied by negative, I get negative 5a. On the right side, 5 plus 9 will give us 14. Once again, we have positive 2b and negative 2b, so they will cancel out each other. So we have 3a negative 5a in this. Will give us negative 2a equals 14. Now, to get a alone, I will divide negative 2a left hand side by negative 2 and the right side 14 by negative 2. So these two negative 2 will cancel out each other, so we get a equals 2 times 1, 2 times 7, 14. So we get a equals negative 7. Now to find the value of b, I'm going to substitute a equals negative 7 in equation 1. So here we have the equation 1, 3a negative 2b equals 5. So we know that a is negative 7, so this equation becomes 3, negative 7, negative 2b equals 5. Let's take the product of 3 and 7. 7 times 3 equals 21 and negative 2b equals 5. So okay, now to eliminate negative 21 from left hand side, or to shift negative 21 from left to the right side, I'm going to add 21 on both sides. So positive 21, negative 20b equals 5, add 21. So we know that positive 21 and negative 21 will cancel out each other. So we have negative 2b equals 5 plus 21, 26. Or you can also take this negative 21 from left to the right side and you will get 5 plus 21, which is 26. Okay, now to get b alone, I'm going to divide negative 2b and 26 by negative 2. So on the left side, we know that negative 2 will cancel out negative 2. And right side, 26 and 2, they have common factor, which means 2 times 13 is 26. So b equals negative 13. So the solution of the simultaneous equations is a equals negative 7 and b equals negative 13. Last part from this question, another part from the question is 5c negative 2d equals 9 and 3c plus 2d equals 7. Now we have two like terms, positive 2d and negative 2d. If we add these two equations, we can eliminate variable d from these two equations. So first of all, let's name them equation 1 and equation 2. And if I add equation 1 to equation 2, then left side of the equation 1 is 5c minus 2d, plus left side of the equation 2 is 3c plus 2d, equals right side 9 plus 7. Simplify 5c, we get 5c negative 2d, and positive 3c positive 2d equals 9 plus 7, 16. Now as we know that positive 2d will cancel out negative 2d, so we have 5c plus 3c, their sum is 8c equals 16. Now to get c alone, I'm going to divide 8c and 16 by 8. So 8 will cancel out 8, so we get c equals 8 times 1, 8, and 8 times 2, 16. So we have c equals 2 for these equations. Now let's find the value of d. Then I'm going to substitute c equals 2 in equation number 1. So here we have equation 1, 5c negative 2d equals 9, since we have c equals 2. So I will substitute c equals 2 in this equation. Then we get 5 times 2, 10, negative 2d equals 9. Okay, next step. Let's take this positive 10 to the right side. Or let's eliminate this positive 10 from the left side. So for this, I will subtract 10 on both sides, right? So 10, negative 10, I'm subtracting 10 from left hand side and 10 from right side. So I will write 10 minus 10, negative 2d equals 9, negative 10. So we know that positive 10 and negative 10 will cancel out each other, so we get negative 2d equals 9 minus 10 will give us minus 1. Okay, now to eliminate negative 2 from the left side, I will divide negative 2d and right side negative 1 by negative 2. So again we know that negative 2 will cancel out negative 2, so d equals minus and minus will cancel out, or minus multiplied by minus we get plus 1 upon 2. So the solution of the simultaneous equations is c equals 1 and d equals 1 upon 2. Next question from this question number 1. Two linear equations. First, 3f plus 4h equals 1, and the second linear equation is 5f minus 4h equals 7. As you can see, we have two like terms with different signs, positive 4h and negative 4h. So let's add them to eliminate h from these two linear equations. So first I will name them as equation 1 and equation 2. Then I will add equation 1 and 2. Then I will simplify this step. So we get 3f plus 4h plus 5f negative 4h equals 1 plus 7, 8. So here we have positive 4h and negative 4h will cancel out each other. So we left 5f plus 3f. And their sum is 8f, and the right side equals 8. Now to get f alone, I will divide left and right both sides by 8. So on the left side 8 will cancel out 8, and on the right side we get 8 upon 8. So 8 divided by 8 equals 1. So if we substitute f equals 1 in equation number 1, we can find the value of h. So equation 1, here we have 3f plus 4h equals 1. Since we have f equals 1, so I will substitute f equals 1 in this equation. Then this equation becomes 3 multiplied by 1 plus 4h equals 1. Now 3 times 1 equals 3 plus 4h equals 1. Now let's take this positive 3 to the right side. So I'm going to subtract 3 on both sides of this equation. So negative 3 plus 3 plus 4h equals 1, negative 3. So we know that negative 3 and positive 3 will cancel out on the left side. So we have 4h equals 1 minus 3 will give us negative 2. So to get h alone, let's divide both sides 4h and negative 2 by 4 Or you can also take this 4 from left to the right side, and we get h equals negative 2 upon 4. Now here we have common factor between numerator and denominator. So 2 times 1, 2, and 2 times 2, 4. So we have h equals negative 1 upon 2. So the solution for these two linear equations is f equals 1 and h equals negative 1 upon 2. Okay, last part from this question is 6j negative k equals 23 and 3k plus 6j equals 11. So first of all, I will name these two equations as our equation 1 and equation 2. And we know that here we have positive 6j's and positive 6j in the second equation. So to eliminate j from these two equations, let's subtract equation 1 from equation 2, because if you add these two equations, then their sum is 12j, because they have same signs, positive signs, both are positive terms. So to eliminate j, let's subtract equation 1 from equation number 2. So first I will write left side of the equation 2, which is 3k plus 6j, minus left side of the equation 1, 6j minus k, equals right side of the equation 2, 11, minus right side of the equation 1, 23. Simplify. So 3k plus 6j, negative 6j, minus multiplied by minus, we get plus k equals 11 negative 23 will give us negative 12. Next step, positive 6j, negative 6j will cancel out. 3k plus k, we get 4k equals negative 12. To get k alone, let's divide left and right side by 4. Then 4 will cancel out 4. So we have k equals 4 times 1, 4. 4 times 3, 12, negative 3. Now substitute k equals negative 3 in equation 1. So here we have equation 1, 6j negative k equals 23. Since we have k equals negative 3, so I'm going to substitute this value of k in equation number 1. Then this equation becomes 6j negative k is negative 3 equals 23. Now minus multiplied by minus, we get plus. So 6j plus 3 equals 23. Now to eliminate 3 from left hand side, or to shift 3 from left to the right side, let's subtract 3 on both sides. So 6j plus 3 as it is, negative 3 equals 23 as it is, negative 3. So now here positive 3 and negative 3 will cancel out. So we have 6j equals 23 minus 3 will give us 20. To get j alone, let's divide left side 6j and right side 20 by 6. Then on the left side 6 will cancel out 6. So we have right side 20 upon 6. Let me divide this left hand side by 6. So coefficient 6 will be divided by 6 to get 1. Okay, so 6 will cancel out 6, so we have j equals right side 6 and 20, they have common factors 2. So 2 times 3 6 and 2 times 10 20. Since 10 upon 3 is an improper fraction, so this fraction can also be expressed as 3 whole 1 upon 3. So the solution of the linear equations is k equals negative 3 and j equals 3 whole 1 upon 3.